Bismillahirrahmanirrahim and Assalamualaikum warahmatullahi wabarakatuh and a very good morning to everyone. So today, me and my group members from group 2, we would like to present about the answers of assignment 1. Alright, hi, my name is Muhammad Izhar bin Razi. My metric number is D2019-108-8310. I'm from 8011, ISMP Biology, and my code is A2.
Hi, my name is Nurul Shazan Hazwani binti Muhammad Zaini. My metric number is D202010955001. I am from ASMP Science 8016 and my code is A11.
Hi, Assalamualaikum. My name is Wan Nushaira binti Wan Muhammad Hassan. My metric number is D2020109562. I'm from 8020. My code is 822.
Hello everyone, my name is Siti Sraini binti Lukman. My matrix number is D2021100352. I'm from 8048 ISM Science Mathematics. My code is A38. Question 1. A curve is defined by the parametric equations x equal to t plus 2 over t and y equals to 2t minus 4 over t, where t is greater than 0. Question A. Show that dy dx equal to 2 plus 8 over t square minus 2, where t is not equal to set 2. B. Find the equation of the normal to the curve when y equal to 2. Give your answer in terms of ax plus by plus c equals to 0. C. Find the second derivative in terms of t. Okay, question 8. To find dy dx for parametric, we need to use chain rule, which the formula is dy dx is equal to dy dt multiplied by dt x. So first, we need to find the dx dt. So x is equal to t plus 2 over t. We can rewrite the 2 over t as 2 the power of negative 1. Then we can differentiate the x as usual. So when we differentiate t, we will get 1. Then we differentiate 2t, the power of negative 1 by using power rule, and we will get negative 2t, the power of negative 2. Then we move t into the denominator by getting rid of the negative exponent. Then we will get 1 minus 2 over t squared. Then we multiply 1 with t squared to make the denominator same. So we will get the answer is t squared minus 2 over t squared. Next, to find the dy dt, we use the same solution with dxt, which is y equal to 2t minus 4 over t, and we write the 4 over t as 4 to the power of negative 1. Then we differentiate the 2t and we will get 2. Differentiate negative 4 to the power of negative 1. We will get plus 4 to the power of negative 2. Then we move to the denominator and we will get the dy dt is 2 plus 4 over t squared. Then we can write as 2t squared plus 4 over t squared. After that, we can easily find the dy dx. We just substitute the value of dy dt, which is 2t squared plus 4 over t squared, multiplied by dt dx. The dt dx is same as 1 over x, 1 over dx over t. So we get the value of dt dx, which is t squared over t squared minus 2. Then we can cancel out the t squared. So we get the dy dx 2t squared plus 4 over t squared minus 2. Next, we need to use long division, which is 2t squared plus 4 divided by t squared minus 2. To get 2t squared plus 4, we need to multiply 2 with 2t squared minus 2. Then, 2 multiply t squared minus 2, we will get 2t squared minus 4. Then we will get the remainder is equal to 8. So, the easiest form for dy dx is 2 plus 8 over t squared minus 2, and finally it is shown as the question given. Any question from my explanation?
I have a question. Can I just show the dy dx by using the long division calculation only?
We cannot use the long division because the long division is just to simplify the dy dx answer. We need to find the dy dx by using chain rule. Is it clear, Zana?
Yes, I see. Okay, thank you.
Alright, for question B, let's take a look at the question first. So the question is, find the equation of the normal to the curve when y is equal to 2 and give your answer in the form of ax plus by plus c is equal to 0. So, from the question, we know that y is equal to 2. So we substitute 2 into y from the equation given. Since y is equal to 2t minus 4 over t, we substitute y with t, so it will be 2 is equal to 2t minus 4 over t. So, we calculate until we get the t squared minus t minus 2 is equal to 0. Next, we factorize the quadratic equation and we will get t is equal to 2 and t is equal to negative 1. But since t is greater than 0, so we reject t is equal to negative 1. After that, we substitute t is equal to 2 into the dy over dx equation. So, it will be dy over dx is equal to 2 plus 8 over 2 squared minus 2. And we will get dy over dx is equal to 6. So 6 is actually the m tangent. Next, we substitute t is equal to 2 into x equal to 2 plus 2 over t. So we will get x is equal to 3. From the formula, m tangent times m normal is equal to negative 1. We substitute 6 into m tangent. And we will get m normal is equal to negative 1 over 6. Next, from the formula y is equal to mx plus c, we just substitute all the values that we get just now into the equation. So it will be 2 is equal to negative 1 over 6 times 3 plus c. So c is equal to 5 over 2. Next, we substitute once again y is equal to mx plus c with the value that we get, but this time, do not put the value of y and x. So it will be y is equal to negative 1 over 6 times x plus 5 over 2. Next, we calculate and put x plus 6y minus 15 to the left side and 0 at the right side. We do this to get the answer in the form of ax plus by plus c is equal to 0. So, the final answer is the equation of the normal to the curve is x plus 6y minus 15 is equal to 0. Alright, do you guys have any question?
Sorry, Ace. I have a question for the question 1b. Where do we use y equal to mx plus c equation? Can we use y2 minus y1 equal to mx2 minus s1?
Alright, thank you Wan for the very good question. So actually, we can also use y2 minus y1 is equal to m times x2 minus x1 formula. We will still get the same answer, but since I'm more accustomed to use the y is equal to mx plus c, so I use the equation y is equal to mx plus c. So, hope that answers your question.
For question C, ask to find the second derivative in terms of t. For parametric, to find the second derivative, the formula is t dx dy dx multiplied with dt dx. So, first, we need to differentiate the dy dx again. dy dx equal to 2 plus 8 over t squared minus 2. We differentiate 2, we will get 0. And for 8 over t squared minus 2, we need to differentiate by using quotient rule, which is the formula quotient rule is vu prime minus uv prime over v squared. So the u is 8, u prime we will get 0, and for v is t squared minus 2, v prime we will get 2t. Then we substitute the value into the formula of quotient rule to get d dx dy dx. Then we will get the answer negative 16t over t squared minus 2 squared. After that, we need to substitute the value of d dx dy dx, which is negative 16t over t squared minus 2 squared multiplied by dt dx, which is t squared over t squared minus 2. Then finally, we will get the answer for second derivative, which is negative 16 to the power of 3 over t squared minus 2 to the power of 3.
Okay, so we move to the question number 2. An ellipse has length of the minor axis is 4 units and the foci at 2 plus set 5, negative 2 and 2 minus set 5, negative 2. Okay, for A, find the center, measure vertices and the zero equation of the ellipse. B, determine the parametric equation of the ellipse in terms of T, and C, sketch the graph of the ellipse. Okay, from the equation, we know that the minor axis is equal to 2b equal to 4 units. So the value of b is equal to 2. Next, from the equation, we have 2 plus z5 negative 2. And for the value of 2, it represents h, while z5 represents c. Okay, as we know, c is the distance from the center to a focus, and negative 2 will represent k. Then, we want to find the coordinate of the center, which is h and k. We can get the value of h and k from the foci coordinate. So, the coordinate of the center is 2, negative 2. Okay, so anyone have question?
Sorry, Dana, I have question. How do you know the minor axis is 2b, not 2a?
Okay, so we know that the ellipse have two patterns. First, we have horizontal ellipse and vertical ellipse. For the horizontal ellipse, the formula for the foci is h plus minus c k. But in the vertical ellipse, the foci formula is h k plus minus c. Okay, then we look back to the foci from the formula in the question. It shows h plus minus c k. So, because of that, we can know the minor axis is B, not A. Okay. Next, we move to the other question about how to find the major vertices. Okay, the major vertices has a formula which is h plus minus A, k. Okay. We already know the value of h and k, but not the value of A. So, we can find the value of A by using the formula which is c squared equal to a squared minus b squared. Okay, we substitute the value of c, which is 5, and the value of b, which is 2. Then, the final answer, we will get 3 for the value of a. Also, we can know the major axis is equal to 2a. So, after we substitute the value, we will get 6 units for the major axis. From this also, we can consider the pattern of the ellipse is horizontal. This is because A and B value will determine the orientation of an ellipse. Then, as points A units, it is left and right from the center, while B units, it is up and down from the center. So, because of that, we know that the ellipse is horizontal. Okay, next. Okay, so we already get all the value, which is A equal to 3, B equal to 2, C equal to 5, H equal to 2, and K equal to 2. Okay, then we know A is greater than B, right? So the standard form equation of an ellipse is x minus h squared over a squared plus y minus k squared over b squared equal to 1. Okay, next slide. Okay, for the last question, we want to find the general equation of an ellipse. So, we substitute all the value that we have into the standard form equation. After that, we will get x minus 2 squared over 9 plus y plus 2 squared over 4 equal to 1. Then, we expand the numerator and we will get x squared minus 4x plus 4 and y squared plus 4y plus 4. And then we equate the denominator and we will get 4x squared minus 16x plus 16 over 36 plus 9y squared plus 39y plus plus 9y squared plus 36y plus 36 over 36 equal to 1. Okay. And then we will multiply all the equation with 36 and arrange it as the final answer is 4x squared plus 9y squared minus 16x plus 36y plus 16 equal to 0. So this is the general equation.
Okay, next for question 2b, to find parametric equation in terms of t. From the question A, we get A equal to 3, B equal to 2, C equal to 5, H equal to 2, and K equal to negative 2. First, we need to find a set of parametric equation for the equation, which is S equal to H plus A cos t and Y equal to K plus D sin t. Next, assign any one of the variable equal to t, which is we let x equal to 2 plus 3 cos t and y equal to negative 2 plus 2 sin t. Therefore, parametric equation are x equal to 3 cos t plus 2 and y equal to 2 sin t negative 2. Okay, from the question 2b, any question?
Sorry, I have a question for Wan. So Wan, can we just use the formula instead doing the calculation?
Okay, thank you for the question. You can use the formula, but I prefer to use the formula let x equal to something equal to t. Okay, we move to question C. Question C need to sketch the graph of ellipse. First, you need to find the coordinate first. Next, know about the two foci of the ellipse, which is 2 plus sub 5, negative 2, and 2 minus sub 5, negative 2. And then, note the major axis A equal to 3 and minor axis B equal to 2. Then, from the question 2A, we get the center 2, negative 2 of an ellipse. And then, after we get all the coordinate, draw a curve shape passing through the endpoints of vertices and you are done.
Alright, that's all from me and my group members. Thank you very much.